Hi everyone, this is Yogesh Babul, and in this video we are going to discuss about how to integrate the Gaussian function over the finite interval 0 to 1 or negative 1 to 1. Guys, in mathematics, the function e power negative x square is known as the Gaussian function. This function is very important and it plays a crucial role in the fields of mathematics, statistics, and probability theory. Here, the integral of Gaussian function from negative infinity to infinity is called as the Gaussian integral. Now, if you search on the internet, you will find different methods of evaluating this Gaussian integral. On the other hand, the evaluation of the integral of Gaussian function e power negative x square over 0 to 1 is somewhat difficult, and there are no elementary, simple or direct methods of getting its value. However, I must say that there are some methods available to approximate this integral, but they are very complex and again they are having less accuracy. So in this video, you will see an easy and more accurate method of approximating the integral of Gaussian function from 0 to 1. So to integrate the Gaussian function e power negative x square from 0 to 1, first of all we need to know the simple inequalities which I am writing here. The inequalities are 1 plus x less equal e power x less equal 1 over 1 minus x, and these inequalities are true for the values of x which are between 0 and 1 including 0. Actually, these inequalities are very trivial and easy to remember. And in fact, the left inequality, 1 plus x less equal e power x is true for all the real values of x. Next, what I have to do, I will take one parameter a which is positive and replace this x by x. Therefore, for a greater than 0, I write 1 plus x less equal e power x less equal 1 over 1 minus x if 0 less equal x less than 1. Okay, so this implies 1 plus x to the power 1 over a less equal e power x less equal 1 over 1 minus x to the power 1 over a, where 0 less equal x less than 1 over a. So what did I do here? I have simply taken 1 over 8 power throughout, and here 0 less equal x less than 1 is equivalent to say that 0 less equal x less than 1 over a. Then I will replace in these inequalities x by x square. So I write 1 plus x square to the power 1 over a less equal e power x square less equal 1 over 1 minus ax square to the power 1 over a, where 0 less equal x square strictly less than 1 over a. Now our integrand is e power negative x square, so we want lower and upper bounds of e power negative x square. So here we are forced to take reciprocals. So we take reciprocals. So after taking reciprocals, we write 1 over 1 plus x square to the power 1 over a greater equal e power negative x square greater equal 1 minus x square to the power 1 over a if 0 less equal x square less than 1 over a. Now let me write these inequalities in a better way. That means I will write first lower bound of e power negative x square and then upper bound of e power negative x square. So I write 1 minus ax square to the power 1 over a less equal e power negative x square less equal 1 over 1 plus ax square to the power 1 over a if 0 less equal x square less than 1 over a. Okay, so I label this relation as 1. This is my first relation. In the next part, we assign some particular values to the parameter a. First, we put a is equal to 1 over 4 in the left inequality of 1 to get the inequality 1 minus x square over 4 to the power 4 less equal e power negative x square if 0 less equal x square less than 4 or equivalently 0 less equal x less than 2. Okay, I number it as 2. Then I will put a is equal to 1 over 3 in the right inequality of 1 to get another inequality, that is e power negative x square less equal cube of 1 divided by 1 plus x square over 3, and this inequality is true for the values of x square which are between 0 and 3. That means 0 less equal x less than square root of 3. And here square root of 3 is approximately equal to 1.73, that you know well, right? I call this inequality as third inequality. Next I will combine these two inequalities. That means I will combine inequality 2 and 3 to get this double inequality. That means 1 minus x square over 4 to the power 4 less equal e power negative x square less equal cube of 1 divided by 1 plus x square over 3, and these inequalities simultaneously hold for the values of x between 0 and square root of 3, as our second and third inequalities are valid for the intervals 0 to 2 and 0 to square root of 3 respectively. Suppose this is fourth relation. So this fourth relation is an important relation which we wanted for our approximation. Then I integrate this fourth relation over 0 to 1 to get integral over 0 to 1 of 1 minus x square over 4 x square over 4 to the power 4 dx less equal integral over 0 to 1 of e power negative x square dx less equal integral over 0 to 1 of cube of 1 divided by 1 plus square of x over square root of 3 dx. Here it should be noted that we can in fact integrate this fourth relation over 0 to 1 or 0 to square root of 3 or 0 to any number between 0 and square root of 3. Okay, then if I call this leftmost integral as I1 and rightmost integral as I2, then it is not difficult to approximate our integral under consideration. That means integral over 0 to 1 e power negative x square dx can be approximated by I1 plus I2 over 2. Once we find I1 and I2, we are done. So we proceed to find I1 and I2. First we take off I1. Therefore, I1 is equal to, as you can see, I1 is equal to integral over 0 to 1 of 4th power of 1 minus x square over 4. That means integrand is 4th power of 1 minus x square over 4. That can be expanded by using a binomial theorem. So I write here the terms of the expansion. They are 1 minus x square plus 3x power 4 over 8 minus x power 6 over 16 plus x power 8 over 256 dx. Now these terms are algebraic and they can be easily integrated. So I1 is equal to x minus x cube over 3 plus 3 times x power 5 over 5 into 8 minus x power 7 over 7 into 16 plus x power 9 over 9 into 256, and limits are from 0 to 1. Now after putting upper and lower limits, we can write 2 over 3 after putting upper lower limits, and then simplifying we can write 2 over 3 plus 3 over 40 minus 1 over 112 plus 1 over 2304 minus 0. Now after doing some calculation, you will get that I1 is approximately equal to 0.733172. So this is approximated value of I2. This is approximated value of I1, not I2. Similarly, we can evaluate I2. Let me first write I2. So I2 is the integral over 0 to 1 of cube of 1 divided by 1 plus square of x over root 3 dx, right? Now to evaluate this integral, we need to make use of substitution method. Therefore, substituting for x over under root 3 as tan t, we get our differential dx as square root of 3 into sec square t dt. Okay. Accordingly, the limits of integration will be changed. So the new limits of t will be from 0 to pi over 6. Okay. So we rewrite I2. So I2 can be rewritten as I2 is equal to integral over 0 to pi over 6 cube of 1 over 1 plus tan square t into square root of 3 into sec square t dt, right? Then after simplifying, it becomes square root of 3 into integral over 0 to pi over 6 of cos t to the power 4 dt. Now you can observe that this is a very elementary integral and there is no issue to evaluate it. So I leave it and directly write the value of I2. So I2 is approximately equal to 0.76192. Thus we have got both the values of I1 and I2. Now we can put these values of I1 and I2 into the previous formula to get our approximation. So integral over 0 to 1 of e power negative x square dx is approximated as 0.733172, the approximated value of I1, plus 0.76192, the approximated value of I2. This is divided by 2. Then doing this simple calculation, we get 0.747567. So this is our approximation to the integral of Gaussian function from 0 to 1, and I think this is a better approximation because this approximated value is very close to the exact value. Exact value is given by square root of pi over 2 into the value of error function at 1. So you can compare these two values with the help of calculator. You can get this and compare with this value. And suppose if you want this integral from -1 to 1, then you need to simply multiply this number by 2 due to the symmetry of the curve e power negative x square about y-axis. So it is 2 into 0.747567. Like this, we have approximated both these integrals. Lastly, I would like to bring it to your notice that our fourth relation is true or valid for the values of x which are between 0 and square root of 3. Therefore, we can in fact approximate the integrals of e power negative x square over 0 to k and e power negative x square minus k to k dx, where 0 less than k less equal square root of 3. So I hope that you understood the topic well. Thank you for watching.